Welcome to Train Signal. You're watching a lesson on computer safety. Now, one thing I should mention when we talk about computer safety, I guess there's two aspects, two different ways we can look at this. One is the safety of the computer itself, right, or the computer and its components. And that's what we're going to start off talking about. We're going to talk about keeping the computer components safe because, well, you may think, who cares? Why do I need to keep my computer safe? Well, you don't want it to break, right? You want to keep your computer safe so that it doesn't break, or the components safe so they don't break, because when they break, you have to replace them. And when you have to replace them, well, that's time and effort on your part as well as money, right, to buy new parts. But the other aspect of computer safety is human safety when working with computers. And I would say that that may be the more important part, because as much as it might cost us money to have to replace computer parts, it costs us a lot more than that if we have to replace human parts, right? Or, if the computer dies, you buy a new computer. When a human dies, that's it, you're done, right? So those are the two things that we're going to talk about, but we're going to start off here talking about computer or computer component safety. And there's this thing here called ESD. Let's talk about what is ESD. ESD stands for electrostatic discharge. It is the idea of you, the human, building up a static charge of energy, okay? And the way this happens is when things rub together, right? As a human, you're moving around. And as you're moving around, certain things may rub together. Your pants, as you walk, your pant legs may rub together. As you move your arms, the cloth on your shirt may rub. If you're wearing socks, the cloth of your sock will rub against the surface of the floor, especially if it's carpet. Matter of fact, I'm going to give you a really good example here. In the winter time, when it's dry, so if you're in a dry climate, and I say winter because I actually live in the Chicagoland area where in the summer it's very humid, and so in the winter is when it's very dry, when it's cold and dry. And you're walking around the house and you have your socks on because it's cold, right? That's why I'm using that example. And you have carpeted floor, right? Because you're in a cold climate area and you don't want the cold floor, so you're walking on carpeting. Well, there's a lot of friction being created there, and with that friction, you're creating all this energy and this static charge. And you may have experienced this. Then you go and you end up touching something metal. Maybe you touch a light switch. You go to turn on a light switch, or you just lean on something metal. Or maybe even another human. You go and touch that other human. You touch something that is conductive, and when you do, you suddenly get this quick little shock. You're like, wow, whew, wow, what was that? Right? You get this little shock. Well, that right there is ESD. That was the energy, that static electricity that was built up in you, discharging, it releasing itself because you touch something that is also conductive. And in some cases, if you're, let's say the room is dark, right? You're in a dark room, you go to reach to go turn on the lights, and as soon as you go to touch the light switch, but before you've actually turned on the lights, you may even see a little spark. Well, believe it or not, these static charges are, very often they can reach like 30,000 volts. And you might be thinking to yourself, man, 30,000 volts, that's awfully high. How come that doesn't kill us? Well, it may be high voltage, but it's very low amperage. Okay, there's not a lot of current involved. It's just one very quick instant discharge and it's over. That's why you feel a quick little shock, tiny little bit of pain that might go with it, but it's very instant and it goes away. Well, guess what? Even though it's a very instant and quick pain that doesn't kill you, the human, that quick little discharge could kill an electrical device. Okay, some of the chips that we have on our motherboards and memory and video cards and all the different components inside a computer, well, they're very sensitive. Matter of fact, in the older days, some of them were so sensitive that you could have as little as 5 to 10 volts killing that particular component. Now these days the components are a little bit more durable than that. But I will also tell you that you as a human, and I've heard different ratings on this, but you as a human don't even feel the shock until you get up to somewhere in the area of like 3 to 5,000 volts. So if you're not feeling it for until you get to 3 to 5,000 volts, but something as little as 5 or 10 volts could kill an electronic device. And again, maybe it's not quite that low, but even if 100 volts could kill an electronic device, you're not even going to know that you just fried a piece of hardware because you touched it. That's all you did. You touched it. Right? You're thinking to yourself, I didn't do that. I didn't feel anything. Again, you, the human, are not going to feel it until after the device feels it. So what do we do about it? Right? How do we prevent this from happening? Well, one way we can do it is by wearing an anti-static wrist strap. Okay, so the idea here is that you will have a strap around your wrist, and in some cases, I've seen it where people will put it around their ankle or maybe further up on their arm. It's designed to be on your wrist, and this wrist strap, what it is basically, if you just picture this little wristband, and there is a piece of metal or conducting material that touches your skin. And then on the other side of the strap, coming off of that conductive material, will be a cord, and that cord will then attach it to some form of ground. Okay, so that way you can't build up a static charge because you're grounded. Okay, so that's the idea behind an anti-static wrist strap, is you are grounding yourself to the earth, and there are many different ways this can be done. There are ESD mats that you can put on the floor. And these are special grounded mats, and you can connect yourself to that mat. Some people will attach to the chassis of a computer, and as long as the computer is plugged in using the 3-prong plug, which will have a ground wire included with it, then everything's grounded. As you create friction and attempt to create this static energy, it discharges straight out of you before it ever has a chance to build up. And that way you can safely touch the computer equipment and not worry about ESD, not giving it that charge because you haven't built up one to convey into it. I mentioned the mat, right? The ESD mat. So you have an anti-static mat, which there's two things about these mats. One, very often they're made of material so that you're walking around on something that is not like some kind of fuzzy carpeting. Two, again, they'll very often have wires running through the mat, which will then ground it to the earth. And another thing, and this is interesting, I put it here, even though it's not really used for ESD, it's just used to help, well, I guess technically it is still ESD, but you want to transport your electronic devices inside of anti-static bags. And that's why I debated about putting it here. The reason I put it here is because the idea is if you have an electronic component and you have it inside one of these anti-static bags, you can carry it around and not worry about accidentally giving it a charge. So even if you cannot be grounded, so you're not wearing a wrist strap, you're not standing on an anti-static mat or anything like that, you can walk around and be creating all the charge you want, but you're not going to fry the device because the device is protected inside of this anti-static bag. Again, try to not work in in carpeted areas. Try not to work like with just socks on. It's much better if you were wearing rubber-soled shoes. There's nothing conductive there. Okay, so you're not going to be able to go ahead and create that charge while walking around in those shoes. And one last thing that I put here, and this really falls, it's interesting. This last thing I have here for removing watches and jewelry and things like that, this is for actually both the computer's safety, because again, these are different conductive devices, and maybe you're not building up a charge, but the jewelry, because it's metal, maybe it's holding a charge, and then it can then accidentally touch something and fry a computer component. But it's also for your safety because you don't want to have some kind of jewelry get caught up in something, or if you touch something live inside of a computer, you don't want to fry yourself because you're wearing metal and that metal conducted the electricity right into you. Okay, so these are some of the things that you can do to help protect the computer equipment from ESD. Now when it comes to electrical safety, what do we have here? Well, we have our power supplies. These are things that can give off, strong electrical charges and can electrocute you. We have power inverters, CRT displays. Okay, so these CRT, the cathode ray tubes, are some of the most dangerous electrical items there are. I mean, thank goodness that computers these days are mostly using LCDs and stuff, but old CRT monitors, you go messing around with those, whoo, there's some scary stuff that can come from that. I'll give you one real quick one. There was so much of a charge that was built up in one of these, and this guy was being stupid, by the way. He was working on a live CRT. So this wasn't even just a CRT that had some kind of a capacitor with a charge that was maintained. It was actually on, and he's messing around in there, and he's got a screwdriver. Well, I don't know what he touched, but when he touched it, there was such a jolt that was given. Now he ended up being okay because the screwdriver actually had, it was either plastic or rubber handles, so it wasn't enough to fry him, but it actually threw the screwdriver out of his hand, and it lodged itself about 20 or 30 feet away from him, completely into a plaster wall. I mean, it was crazy. And by the way, I was in the room with the guy. I was standing only about probably 3 feet from the guy. Imagine if that screwdriver, instead of going the other direction into the wall, would have come towards me and it would have went through me. Okay, so really, really dangerous. And as we talked about in the printers lesson, there can definitely be some dangerous components inside of a laser printer. Both electrical, right? Because we talked about the electrical positive and negative charges that are going on with the different wires, as well as the heat. But we're talking about electricity here. So you want to make sure that you keep yourself, right? This is now personal human safety when dealing with these types of electrical devices. Now, one last thing that I will mention with regards to electrical hazards, right? The main thing I would say is when working with these particular devices is, well, make sure that they're unplugged and off. But I want you to keep in mind that even if they're unplugged, even if they're off, there are capacitors which will hold, they will maintain energy and electricity inside these devices. So don't ever assume that they're safe. Okay, and so again, I want to kind of go back to the whole wear rubber-soled shoes, that keeps you grounded, remove the jewelry, as I mentioned before, and just please be careful to not allow yourself to become what's called the ground. Okay, don't allow yourself to be touching what eventually goes into the earth, because that means that these charges can discharge into you. Okay, if you're not a conductor, right, if the energy can't pass through you, then you're, for the most part, okay, right? We talked about how that static electricity, right? It's not the volts, it's the amps, right? You can get 30,000 volts, but it's low amps. You don't want a lot of amperage discharging through you. It can go into you as long as you're not creating a ground. The one last thing I want to mention is I mentioned about having these things unplugged and off. Well, a little while back, I talked about protecting the computer equipment by having that anti-static wrist strap, right, or that ESD wrist strap that you then sometimes clip onto the chassis of a computer if it's plugged in. So this is where there's a constant debate that goes back and forth as to whether a computer should be plugged in or not when working on it, right? Because if it's plugged in, then you can clip yourself to it and you're protecting the equipment because you're grounding yourself, right? So you can't build up a charge. But the reverse side of that is that means you are now ground, right? You're grounded, which means if you touch something that is of high electrical hazardous material, you're now at risk. So you have to really take a look at what it is that you are doing. And this really is something to pay close attention to, even if you don't think that you're working with anything that is of extreme danger. I mean, I'll tell you what, I can remember working on a friend of mine, working on his computer, and I was in his basement, and it was a snowy winter day, and so my shoes and socks got all wet, and so I removed them both when I went into his house. I'm now in the basement of his house, and it's an unfinished basement with a concrete floor. So now my bare feet are touching the earth. They're touching concrete floor. I didn't think I was doing anything dangerous, but strangely enough, I kept getting this little warming sensation as I was messing around with certain components inside his computer. What I didn't realize is that even though I was not using anything, I wasn't touching anything that was on the list here of real dangerous electrical hazards, but what I didn't realize is that apparently his power supply had some kind of a weird short in it, and even though the computer was off, it was giving some kind of a electrical charge to the chassis of the computer, and I didn't have a wrist strap. I was just keeping my hand holding onto the chassis of the computer. So now I'm touching the chassis of the computer. The power supply's bleeding an electrical feed in, from the wall outlet into this chassis, and I'm now barefoot on concrete. Guess what? All that electricity, that leak that the power supply was giving, was feeding through me. And that's why I kept getting this warming sensation. And it was weird. It was a warming, tingly sensation. Not enough to, knock me out or give me a big jolt across the room or anything, but it was enough that I was like, this is really weird. And eventually I figured out, like, oh, I need to stop this. I need to go put my shoes on because something's going on. It was also a good clue to me that something was wrong electrically with his computer, which allowed us to then swap out the power supply with a new one so that that problem wouldn't become a bigger problem and wouldn't be a hazard any longer. Okay. Let's move on past our electrical hazards here and move into a different type of electrical hazard, which is electrical fire safety. Here's the deal when it comes to electrical fires. Your fire extinguishers have different classifications. You have a Class A fire extinguisher, which is for things like just your standard paper, wood, cardboard, your regular fires. Okay? You have your Class B fire extinguisher, which was designed specifically for things like gasoline fires, a combustible liquid. What you want to look for when dealing with computer equipment, and you want to have nearby when working with electrical computer equipment, is a Class C fire extinguisher, which is specifically designed to deal with electrical fires. Now from there, I will go ahead, as long as we're going through the different classes here, we do have Class D, which is for chemical fires, and Class K, which is for oil and grease. But again, what do you want to keep around your computer equipment? You want to have nearby, in case there's an electrical fire? Class C fire extinguisher. All right, now when it comes to additional physical safety, right, for you yourself, the human, there's things that go beyond just getting shocked when dealing with computers. Very often, if you're going to work with computers, you might be carrying things around. It happens all the time that you're lifting computers, computer equipment, and although a single computer or monitors these days, if they're not CRT, they don't tend to not be that heavy, you might be carrying a stack of them. Okay, so keep in mind, for the most part, if you're going to carry, they say more than 25% of your own weight. Okay, so if you weigh 100 pounds, if you're going to carry something that's more than 25 pounds, ask for help. Now, I know that might sound a little ridiculous to you. I know it does to me. I mean, I weigh around 150 pounds, and I will carry 100-pound things myself all the time. I shouldn't be. I'm just stubborn that way. Not a good idea. Now, if you are going to lift something heavy, please make sure that you are using your legs, not your back. Okay, so what it means is when you bend over to pick something up off the ground, bend your knees, use the muscles in your legs, not bending over at the hips and using the muscles in your back. And I know this might sound ridiculous that I'm telling you this. You hear it all the time, right? Lift with your legs, not with your back. But it's true. A lot of computer professionals have really bad backs. I know a lot of IT people who walk around wearing a belt, a lifting belt. Not just because they're lifting stuff all day, but now they wear it just because they have a bad back because they didn't lift properly. Oh, here's another hazard. Cable management. Ever seen a wiring closet that looks like this? Just a big old mess? Yeah. You definitely probably want to put up one of these little caution labels because that's a problem. When you have cables running all over the place, it's a tripping hazard. Now, besides being a tripping hazard, it also can cause ventilation issues. Okay, so the computer equipment itself could be at risk. I'd say something like this looks much better. Now, I mentioned just a few moments ago, we were talking about laser printers, right? Being an electrical issue, right? An electrical hazard. It gives off a lot of energy because you have all the different charging components. And I mentioned that another thing with the laser printers is, well, you have the fusing assembly, which is very hot. So please keep in mind that different electrical components can also get very hot. And so you want to make sure to protect yourself against burns. Some of the components that do get hot are your power supplies, your processors as well as the heat sinks. I mean, let's be real, the heat sink is specifically designed to take heat away from the processor. And I mentioned the laser printer fusing assembly. All right, so keep in mind, you have electrical hot, but you also have physical hot. Now, when it comes to environmental safety, there are a number of components involved with computing that you have to make sure that you dispose of properly because they can cause a hazard in the environment if you're just throwing them in the dump. Okay, you have your circuit boards, your toner cartridges, CRT monitors is a big one. That's a big deal. Don't ever throw a CRT television or monitor in the garbage. You don't want to do that. Batteries, that's another big one. Don't just throw them away. And people do it all the time, but it really does cause a big hazard. You don't want to be putting them here. When you put these different hazardous pieces of material in a regular garbage can, okay, I don't care if it's at your house and you put it in the can under the kitchen sink, or whether you're at the office and you're putting it in the dumpster out back, this is where it ends up. What you want to do is go ahead, and there's many different companies out there that are specifically equipped to safely dispose of this equipment. So this is what you want to be doing. You want to be calling them up and making arrangements for them to pick up your stuff. And in some cases, they may recycle certain things, or in other cases, they are subsidized by the government and other organizations to maybe even give you a little bit of money for your old equipment that to you is just garbage. But because you're safely disposing of it, you might even be able to make some money off of it. And I shouldn't say make money, but get a little money for it. And so that does bring us to the end of this lesson where, again, we talked about both the safety of your computer components themselves and your safety as a human. The main thing when it comes to computer safety is making sure that you avoid ESD, electrostatic discharge. But when it comes to your safety, you got all kinds of stuff. You want to make sure that you don't get a big old electrical charge, right? You don't want to get electrocuted. You don't want to touch something hot. You don't want to get burnt. You don't want to pull a muscle by carrying things that are too heavy for you. Make sure you have a good fire extinguisher in case there is an electrical fire. And of course, what's the rating on it? It's a C-class rating. Make sure that you are properly disposing of things. And, I should also mention the cable management. I bring it up, quite frankly, because it's part of the CompTIA objectives. But it is a reality your cables can cause all kinds of problems. And could be a problem to you, the human, as well as the computer equipment itself. So with that, I thank you for watching this lesson, and I will see you in the next one.